So the first thing I would do is, let's find the objective function. The objective function, again, is basically a formula that I'm looking for, and it needs to represent the thing that I want to either maximize or minimize. We want to maximize profit. We need to maximize profit. So our objective function should represent profit. It represents profit. So I need to write down some kind of formula with variables and stuff that'll represent my profit. So it should depend on how many roller blades I produce. Yeah. So here's what I would do. If you want to write down an objective function, the first thing you need are variables. So we need variables. And what should my variables be? Well, they should be the things that I don't know, but kind of need to know. And what do I need to know? Well, if I want to, I'm basically asking how much of each kind of skate that I need to produce, right? I've got the California and I've got the Florida. So maybe you'll have X represent the, maybe, yeah, we'll call it X. We'll call X the California model, and the Y will be the Florida model. I want to stick with calling them X and Y because later on we're going to be graphing. And so it's convenient to have X and Y axis to sort of line up with what we're used to. So the X will represent the number of California models produced, and Y will represent the number of Florida models produced. Okay. Once we have our variables, I just need to write down the objective function to represent the profit. And so generally for the objective function, I'm going to use this capital letter P. You might, in this case, think of P for profit. And I'm just going to say P equals, and then I'm going to write down something that represents the amount of profit that I'm going to get based on how much of each model that I make. And what did we know? We know that I get $15 for every California model, and I get $18 for every Florida model. So my objective function had better be 15x plus 18y. Should be my profit. So again, they just said that the profit for a California model is $15, so 15x. And profit for a Florida model is $18, so 18y. And then I add them together to get my total profit. So P equals 15x plus 18y. This is my objective function for this problem. Okay, so there's our objective function. Again, we're just looking for the thing that I need to either maximize or minimize. So in this case, maximize. And then I just need to represent it as a formula involving variables, which represent whatever objects I'm talking about in my problem, in this case, roller blade. Okay. So this is only the first step of setting this up, is finding the objective function. The next step is to find constraints. So now I'm looking for inequalities. I might have a bunch of inequalities that I need to worry about. So let's just remember what this objective function is. I will summarize everything at the end for this problem on one board. But let's move on. Let's look for constraints. Next, find constraints. So the constraints are some inequalities. And I remember that I told you that there are two types of constraints. There's explicit and there's implicit. We will look for the explicit constraints first. So I'll remind you that explicit ones are ones that are just sort of given to us in the problem. They're in the information of the given problem explicitly. And so what do I mean? Well, in this case, what information have we been given? We've been given this information about how much time it takes to produce each kind of skate, or yeah, how much time it takes to do each operation to produce a skate. And they also told us that we have a certain amount of time available, right, in total. We only have 120 hours available per day. Of course, this is man hours, so this makes sense. 120 man hours available per day to produce skates. This is going to give us a constraint because I'm limited by how many man hours I have per day. I don't have unlimited time per day to produce skates. I'm limited by how much time there is in a day and by how many employees I have, for instance, right? So I have this upper limit. So that constrains my ability to produce roller blades. And so we just want to capture this with a mathematical expression using an inequality. So probably what's going to happen is I have some less than or equal to 120, because 120 is like an upper limit on the amount of time I can spend, right? I can never spend more than 120 hours. We should be a little careful. Remember that this table was given to us in minutes, and this is given to us in hours. And so we might have to convert units here. So that can be a little tricky with some of these problems, is keeping track of units. So let's keep that in mind. Okay. Oh, and yeah, this was for each job, by the way. So 120 hours available per day for each job, right? There's 2 jobs. I can't remember if that before or not. But anyway, 120 hours per day for each job. So let's convert these into constraints, right? Because I know how much time it takes to produce, to do the frames for the California and the wheels for the California, and similarly for the Florida. Let's convert these into maybe 2 different inequalities. So there'll be like a California inequality. And what's that going to tell me? Well, or maybe not, sorry. Let's back up. I have 120 hours per day available for each job. So what I should have is a inequality for each job. I should have a frame inequality. This makes more sense. And then I should also have a wheels inequality. So what do I want to say? Let's look at frames. How can I tell how much time I'm spending on frames between the 2 models? Well, it takes 15 minutes to produce a California. So for every California, I'm spending 15 minutes. We should convert 15 minutes to hours. That's a quarter of an hour, which is 1/4 maybe. So let's say 1/4 x for 1/4 of an hour, aka 15 minutes per California model, right? And then to add to that, it takes 10 minutes to do a Florida. Maybe I want to do this in decimals. Nah, I won't do it in decimals. This is just 1/6, right? 10 minutes is 1/6 of an hour. And so Florida is represented by y, so I take 1/4 x plus 1/6 y. And then this has to be less than or equal to 120 because that's the upper limit on the amount of time I can spend. Okay. So for frames, I can represent the amount of time being used to produce frames by adding up the total amount of time per model. And it takes 1/4 of an hour for each California, and it takes 1/6 of an hour for each Florida model. And I add those together to get the total time. And then that has to be less than or equal to 120 because I only have that much time available for this job per day. Okay. I do the exact same thing for the wheels. I convert these minutes into hours. So what's 5 minutes? 5 minutes is hang on, is that 1/12? 1/12 of an hour, if you will. If you prefer decimals, you might write these as decimals instead, but I'm going to stick with fractions. So this is 1/12 of an hour for each California, so 1/12 x plus 20 minutes for a Florida. 20 minutes, that's a 1/3 of an hour. So 1/3 y. And then again, this is less than or equal to 120 because I only have 120 hours in a day for each job. Okay, so these are my explicit constraints right here. These inequalities are my explicit constraints. Explicit because I got them from the information that was given to me explicitly in the problem, right? When I wrote down the problem, I explicitly wrote down all of this information, just not in this format. We then converted it into these inequalities. Okay. So I better mention then what are the implicit constraints? And these are kind of dumb, but you can't forget to use them. If you ever forget to include these, your problem will most likely end up being wrong in the end. And so these are not given explicitly. But without them, the problem makes no sense. So implicit constraints are going to be some inequalities that were not given to us in the problem, but if I don't include them, then the problem doesn't make sense. And so what do I mean? Well, I'm basically just going to tell you in this case what they are, and then I think it'll make clear, or clearer, what this is really supposed to mean, and what's the purpose of these. And the idea is this. X represents the amount of California models that I'm going to make. Would it make sense to say that I'm going to produce -5 California models? No, that doesn't make any sense, right? Having these be negative would make no sense. And so I better include this additional constraint that just says that X is greater than or equal to 0, i.e. X is not negative, so that this makes sense. That's all I'm going to do. And this was not told to me in the problem, but if we just think about what the problem is saying, what I'm dealing with producing roller skates. Realistically, it doesn't make sense to talk about a negative number of roller skates, so I better just insist that my variable is never negative. Same thing for Y. I can't produce a negative amount of Florida roller skates either, so I better just also include that that's not negative. These are my implicit constraints. So you basically always need to remember to include your implicit constraints, and almost always they're just going to be these two inequalities. So almost always you just need to include these with your other constraints. If you don't, you're going to run into problems when it comes to solving this, solving these problems later. So just keep this in mind. We can't forget these. I've had many students in the past come to me complaining that they couldn't solve a problem. They kept getting the wrong answer, and it turned out they forgot to include their implicit constraints, and that fixed everything. So remember your implicit constraints. They are the things that we need to make sure that the variables even make sense for a real world situation. Okay, so let's see. Let's summarize everything in a nice handy on an all-in-one board here together. So we found our objective function. It was P equals 15x plus 18y, and this represented profit. So this represented our profit in dollars. And then we had our constraints, which was a big system of inequalities. So what did we have? We had 1/4 x plus 1/3, sorry, not 1/3. What was the other one? It was, 1/12. Less than 120. And then I had this is 1/6. This is 1/12. 1/12 x plus 1/3 y less than or equal to 120. And then I just had to insist that x is greater than or equal to 0 and y is greater than or equal to 0. So in summary, I have all of this information that we're going to use to solve our problems, to solve this problem. I have my objective function and I have these constraints. And I'll just remind you, these were implicit. And the other two were explicit. Some really loud thunder all of a sudden. That really just caught me off guard. I don't know if you guys are in Bloomington and could hear that, or if you guys are somewhere else. It sounded like it was right outside my window. Anyway. Here's our setup. Okay. Cool. Okay, so we've set up a problem. Again, we haven't really done any math, and I'm not going to solve this for you yet. We'll see how to solve these kinds of problems later. For now, let me pause and see if there are any questions. And if not, I will definitely do another one, maybe a little more streamlined. Okay, so it seems like there's no questions. Let me do another one. Maybe I'll fumble a little bit less on this next one. Maybe I didn't fumble that much on this one, I don't know, but I feel like I did. Let's do another example.